3.4 Product and Quotient Power Law, or Power Laws, Part 1. Make sure that you put your name up top. Mine's Kara. And the date, whatever your date is. So when we see product and quotient, sometimes I see my students' eyes just kind of glaze over, like, what? Remember, product is always just multiplication, and quotient is just a real fancy way of saying division, okay? So if you, it's the power laws that deal with multiplying powers and dividing powers. So when we multiply and divide powers with the same base, okay, something amazing happens, okay? We can make some rules here that make the calculation much simpler. So this right here, this is only for powers with the same base. So if we look at our product of powers, and remember that's just multiplication, we're going to see an example here. 3 to the power of 2 times 3 to the power of 5. Now if I were to write this out in repeated multiplication, I would just say 3 times 3, okay, that's the same thing as that 3 squared, times 3 times 3 times 3 times 3 times 3. That's the same thing as our 3 to the power of 5. So let's see how many we have here. We know that when we write it as a single power, we have a certain base. Let's count how many 5s we have. 1, 2, 3, 4, 5, 6, 7. I want you to think for a second. Look at this. How do I get from 2 and 5 to 7? We can make a special law right now. We can say that when we multiply, or we can say with product of powers, so when multiplying, and remember this only is for same base, we add exponents. So 2 plus 5 is 7. The base remains the same. Nothing happens to the base. We don't say 9 times 9 and that, or sorry, 3 times 3 and it becomes 9. The base stays the same. Kind of like the denominator in a fraction. What happens when we divide? Well, let's give an example here. 7 to the power of 8 divided by 7 to the power of 6. Let's write this out using repeated multiplication. So on the top we have 7 times 7 times 7 times 7 times 7. 1, 2, 3, 4, 5, 6. That's weird. 7. Ooh, I'm going to put 1 in the beginning here. 8. Okay. Divided by 7 times 7. No. 7 times 7, and then times 7, times 7. 1, 2, 3, 4, 5, times 7. Whew! That's a workout. So you can see why we don't do repeated multiplication all the time. This is why we develop laws, so that it's much easier. So what I'm going to do is I'm going to cancel. If I have 7, and I divide that by 7, I simply get 1. So this is called canceling. If I cancel a factor in the numerator, I can cancel in the bottom, in the denominator. Same with this one, 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 and that's it. Now all we have left is 7 times 7, which we know is 49. But look at that, it's 7 to the power of 2. How do we get from 8 and 6 to 2? 8 minus 6 is 2. So when dividing, subtract exponents. Okay, so we're going to define it a little bit more formally here, but essentially this right here is the law. This right here. Okay, that's all you need to know essentially. But let's write it a little bit more officially. So the first one. When multiplying two powers or more with the same base, add exponents. So I'm going to get a little bit more abstract here. A to the power of m times a to the power of n. So we both have the same base. We have a as our base there. That is the same thing as a to the m plus n, where a cannot equal 0. So the base can't equal 0, but for every other number that is given to us, that works. Now here's the other one. When dividing powers with the same base, subtract exponents. So our little example here with algebra, if I have a to the power of m divided by a to the power of n, which is the exact same thing as if I say a to the m over a to the n. That's the same thing as a to the m minus n, where a cannot equal 0. Now the reason why a cannot equal 0 in this case is because if I would put a 0 here, it would mean that the denominator would be 0. And we'd have a 0 over 0, and that's not good. Like, try putting that into your calculator, okay? Say 8 divided by 0. Cannot divide by 0. If that is kind of confounding you, come and talk to me, and I'll tell you that you can actually do it. It just goes to infinity. Dun, dun, dun. So come and talk to me about it if that intrigues you. If not, and I can't blame you for that, let's move on to the examples here. So write each expression as a single power and then evaluate. Okay, so they're kind of like two steps. Single power and then evaluate. With a single power, this one right here is where we use power laws. So I have 8, so 4 to the power of 3 times 4 to the power of 5. But since we're multiplying, and since they have the same bases, we're going to be adding the exponents. So 3 plus 5, which is 4 to the power of 8. Now that is going to be a big stinking number. So let's see what that is. 4 to the power of 8. 6, 5, 5, 3, 6. So remember, we have both of them. We have the first answer, which is as the single power, and then we have this answer right here, which is evaluated. All right, so let's look at the next one. We have -5 to the power of 7. We're using division here, so that means we're going to subtract the exponents because the bases are the same. So 7 minus 4, which is going to be -5 to the power of 3, which is going to be -125. I can just know that from my head. Now, there are two parts of the answers. This one right here, which is our single power, and this one right here, which is our evaluated version. Now, this is where it kind of spices it up a little bit. We have two different questions here, and they kind of involve both multiplication and division. So whenever you see something that looks like this, do not be afraid. Remember that when we see multiplication, we add exponents. Division, we need to subtract exponents. Okay, and we know that all the bases are the same. They're all 7. So we can use our exponent laws. So 7 to the power 3 plus 4 minus 5, which is 7 to the power of 7 minus 5, which is 2. So this one right here is the single power. And if we wanted to have the evaluated version, it would be 49. Let's look at this one for a second. I see a multiplication, okay, so I know that I'm adding exponents. And I see a division, so I know that I'm subtracting exponents. But look at this. There is no subtraction law. So we can't use the quotient or product law for this portion. So what we can do is we can simplify it as much as we can here, but then we need to actually evaluate to finish the question. So here I see bases are the same. I see 8. And I see multiplication and division. So I'm seeing 8 to the 7 plus 6 minus 11. And then I just have a regular old minus 8. This is kind of like our BEDMAS. So we have to finish the exponents first and then we do our subtraction. So I have 7 to the power of 6, which is 13 minus 11. So it's 8 squared minus 8. So this is as best as we can do here. So I go 64 minus 8. 64 minus 8 is going to be 56. This is all I can do. So note, it is not possible to write example 2b as a single power. Why? Because there's no subtraction law. So, in summary, we add exponents when we multiply powers. We subtract exponents when we divide powers. But this can only happen if bases are the same. The math excels that I want you guys to